Hey, have you ever wondered how to synthesize mono Pygame audio using an n-dimensional NumPy array? No, right? Well, I had to. I'll first explain some of the very in-the-weeds calculations and then get into the code itself, though I'll also have a pastebin link to the code in the description. To develop an understanding of sound generation, an understanding of the properties of sound is required. Say I have a sine wave, which is just squiggle. Sine waves and all waves have a crest and a trough, and one crest along with one trough is called a cycle. Now let's suppose this wave took 1 second to complete. That means that there is one cycle per second, therefore the frequency would be 1, which is also measured in hertz. Now another point is that the amplitude of a sound wave is how much it travels from its median point. So in this case, the amplitude would be this line. Now, how do these two variables affect sound waves? Basically, frequency determines the pitch of the sound wave. Meanwhile, amplitude determines the loudness of the sound wave. You might notice there's actually one variable missing here, which is the quality for a digital sound wave. The quality is determined by the sample rate. Let's suppose this wave took 1 second to complete. The number of measurements or samples that are taken during this 1 second is called the sample rate. Now, the higher the sample rate, the higher the quality. We will generate a time array with NumPy that is linearly spaced to determine these samples. We'll go from 0 to whatever time we want. So 1 second, 2 second, whatever. Now the question is, sure, we have the frequency and the time or the duration that we want our sine wave to take, but how will we turn that into radians to feed into the actual sine function? Basically, we'll just multiply these two values because frequency is the number of cycles per second. Meanwhile, time is also measured in seconds. Therefore, these two values will just cancel out and we'll get the number of cycles. Where one cycle is just equal to 2 pi. Therefore, to convert the cycles into radians, we'll multiply 2 pi with the cycles we get. Once we hand the sine function our value in radians, what will it return? It will return the y coordinate. Let's take a point in this unit circle. Radius is equal to 1. This point will be pi over 4, and let's measure the y coordinate manually. This will return 0.7, where sine of pi over 4 is 0.7. As you may notice, this is also the perpendicular of a triangle, i.e. the adjacent. Our next step is where the amplitude comes in, because our sine function is going to hand us values ranging from -1 to +1. If we use this by itself, it would result in a very quiet sine wave. Therefore, to increase the loudness, we'll multiply the array with the amplitude. So let's start off with import statements. There are two dependencies here, and they're both external libraries. You can download these with uv, pip, whatever installed. For initialization, you could either pre-initialize with your arguments and then initialize Pygame itself, or you could initialize just mixer. And the one change here that I'm going to be focusing on is channels, which I'm going to be setting from 2 to 1. This changes the audio from stereo to mono, and it's because of how simple the NumPy array we're going to be using is. However, it could also be that we change the NumPy array itself instead of initializing mixer differently. So I'll define some constants here, but you don't actually have to do this. What you could do instead is pass in all your values into your functions. And this is kind of an example of how you don't have to follow this exactly for it to be functional. Now the first function I'm going to define will take in the frequency and then the duration or total number of seconds and return an n-dimensional NumPy array. Firstly, the time array will be defined following the parameters of this function, where the start is 0, the stop is the total number of seconds, and the num here is the number of samples. So we'll multiply samples per second by the total number of seconds, and then we'll disable the endpoint, though to note this does not quite affect the actual sound itself. Next, we'll pass this array into the sine function. Then, to convert it into cycles, we'll multiply the seconds with cycles per second. To convert that into radians, we'll multiply it by 2 pi. As we know, the sine function returns an array of values ranging from -1 to +1. So I'll make sure to multiply this with the amplitude and then apply PCM16. Now I'll define a function that will return the sound object itself, which should be able to be played with the play method. First we'll get the sound array from the other function with the same arguments. Then we'll have to convert this array into a sound object. If you take a look at the docs, we can either do this by passing it in as the array argument in Mixer's sound class, or we could use pygame.soundArray.makeSound, which I'll be using. Now, as a note, if we're going to be playing this directly, you might have to add a sleep after. So let's say I want a sound that is of 440 Hertz and I want it to be 1 second long. I can sure play it with the play method, but then I might have to add a sleep after to actually hear that sound being played. Another note is that your audio may be affected by your device and operating system. Alright, that'll be it for now. Thanks for watching.